Perhaps one of the most synthetically useful things we can do on benzene involves a group of reactions that involve what are called aryl diazonium salts. And so, the structure of which is, I'll show that in a sec, the formation, has got two nitrogens bound through a triple bond. You essentially have a molecule of nitrogen gas on your molecule, which is an exceptional leaving group. Because as soon as it does leave its N2 gas, it bubbles away, it's out of the reaction, equilibrium drives the reaction forward. Of course, because it's on a benzene, it cannot leave right away, which is something special. So this reaction is actually covered in the Klein textbook in the amines chapter, which is chapter 22. So I'll just note that. This reaction, or this set of reactions, is covered in chapter 22. And it involves taking an amine and treating it with sodium nitrite and HCl. In doing so, we'll get this, what's called an aryl diazonium salt. So diazonium, two nitrogens. So this is what's called an aryl diazonium ion, stabilized by the chloride. Let me try that again. ARYL. There we go. And what's very useful about this is we can do a lot of different things with it. First and foremost, treating this with different copper 1 salts allows us to install a variety of groups directly on. So you can add copper 1 chloride, copper 1 bromide, copper 1 iodide, or copper 1 cyanide. And while the first two may not be terribly interesting because we already know how to put a chlorine or a bromine on, they're still synthetically useful because sometimes we need to install things using an amine and then later turn it into a bromine. Something like that may be very synthetically useful. So we're going to see that treating the aryl diazonium with copper 1 chloride puts a chlorine on. With copper 1 bromide, you put a bromine on in the place of your diazonium. You can put an iodine on. So this is one way to put an iodine on there. There is another way that's less common, but this is a great way to do it. And you can also put a nitrile on. So you can put a cyanide group onto your benzene as well. So using these various copper 1 salts. These are called the Sandmeyer reactions, by the way. And as you can see, it's allowing us to do a variety of different things once we have an amine in place. We can convert it to the diazonium, and from there we can install different groups. And while yes, you may say that yes, we've already covered chlorine and bromine, we did not see something for iodine or for cyanide. So that at least is two reactions in of itself that are new, or two substituents that are new. But as I alluded to, when we talk about putting multiple things on a benzene, it can be very useful to switch groups, to interchange groups, to put a bromine where we didn't have a bromine before, or where it would be difficult otherwise to try and put a bromine in. And there are other things we can do with this. We can take our diazonium, treat it with fluoroboric acid, HBF4, and now we can put a fluorine on. So the copper 1 fluoride will not work, but if we use fluoroboric acid, HBF4, we can put that fluorine on there. Again, very useful. Many drugs, in fact, have fluorines on benzenes that are otherwise very difficult to put on. So using this diazonium species works well. We can also, it's a whole chapter in and of itself. If we take that diazonium, treat it with water, a little bit of heat, now we can have an alcohol on there. Again, not something easy to put on with electrophilic aromatic substitution. So Not an easy group to put on there. OH is not a nuclear or electrophile. It's a nucleophile, right? So not very easy to put on. But using this, we can nitrate, form the amine, form the diazonium, and now we can put an alcohol on there. Very useful again. Thought we're done? Nope. Another one. What we can do next is treat this with phosphorus acid, H3PO3. And what this does is it just removes the diazonium. So again, just like we could remove a sulfonic acid group in SO3H, we can remove a diazonium, which means we can remove a nitro group, or we can remove an amine, either way. Remember, a nitro group can be turned into an amine, which can then be turned into a diazonium, and now we can remove it. So, a lot of different things here. So we can now add fluorines, iodines, cyanides, and alcohols onto our benzenes, indirectly using this diazonium. And there's one more reaction that's a little bit different, it's a little bit special, which is called an azo coupling. What we do is treat our diazonium salt. And I'm just going to put a methyl group on this just so we have some difference here. If we treat this with another benzene, specifically one that has what's called an activating group, we're going to cover activating groups later on, but something like an OH is an activating group, or an NH2. There are a lot of different activating groups. So it suffices to say, as long as your benzene has what's called an activating group, again, something to be covered in a little bit, it'll react. And how this reaction works is we're going to have our electron donating species actually couple the two benzenes together. So we're going to resonate electron density towards the opposite side of the ring, which is then going to act as a nucleophile, because our diazonium is actually an electrophile. So we can do an electrophilic aromatic substitution using the diazonium as our electrophile. And in doing so, we will now end up with, just like any EAS reaction, I'm going to just keep the rest of this the same. We have our nitrogens. I'm going to correct the geometry here. Technically speaking, we have the resonance form with its extra hydrogen there. And just like before, we're going to have a base come along. Perhaps it might be water, perhaps something else. Some sort of base will come along, grab that hydrogen, and we will end up restoring our OH group, restoring aromaticity to that ring. And now we have an azo compound, as they're called. So, 1, 2, 3, and N. We're essentially connecting two aromatic compounds together through that azo coupling, which is right here. This is an azo group, and that's coupling the two rings together. Notice there's extra conjugation, and interestingly enough, these compounds are often very brightly colored. Azo compounds are. So you see them as dyes very often because of all that conjugation. And that's, in fact, a video we'll cover also next week when we talk about UV-vis spectroscopy. So, that's it for all of our reactions. So many of them. You're going to want to get familiar with these, because next week when we talk about activating groups and directing groups and nucleophilic aromatic substitution, and then we're going to really get into the fun part of this chapter, which is on synthesis problems. Starting with benzene, can you make something with 4 different substituents on it? Can you put an OH on one part and put an isopropyl group and put an amine and put something else, whatever. I have a lot of fun with these. because there's so many things I can do. Right now we know how to put one group on. We don't know how to yet put two groups on, or how those affect each other. Because there are 6 positions in the benzene, right? We know how to put something on one of them. And so next week we'll look on how to put multiple together. So for right now, study all of these reactions, really get them down, and next week we're going to put them into effect. Alrighty, have fun and enjoy these videos.